a little bit further about what happens, looking at signals and their various representation. Now, one thing you may be getting familiar with, or may not, is the fact that if I have a signal that's periodic, such as this particular structure, and I can look at that and I go, well, what is its representation in frequency? And I think, well, okay, I have a sense of Fourier series, and if I take this periodic signal, it means that I can get various coefficients to represent what that signal might be. And in fact, for this particular signal, around 0, that has a very nice, that sort of has an odd symmetry to it, I get these various individual coefficients. So, the coefficient in the first, third, fifth, and so forth. And so I get these various levels. The interesting question is, I can talk about multiple different periodic signals, and if I get periodic signals, I get these representations. And you talk about the frequency coefficient, you remember that this is really things that are periodic from its 0th order, from its sort of fundamental frequency. And so in a way, this is really a representation of frequency. And you think, well, that's kind of cool, right? You're thinking, so I got time and I have frequency. What happens if I start talking about a more general signal that has no periodicity? Well, how do I think about it? Well, it almost looks like the periodicity becomes infinite. So these points become closer and closer together to where I eventually get a continuum. That becomes interesting, because then I start saying, imagine I have an arbitrary signal like a speech signal. And this is sort of a typical speech signal where you get the typical speech in very clean environment and then, quiet spots and so forth. Very typical kind of thing over, say, 5 seconds of speech. But what you get out of this is then you can say, well, imagine I have I can say, well, is there time and frequency information? And this is where it becomes very important that there actually is both things. And in some sense, you can argue that the Fourier series becomes a Fourier transform, sort of the continuous version of this. But even more interesting then is you can say, what happens in looking at frequency and time simultaneously? Now, there's a whole bunch of questions of accuracy and discussions there. But to begin to see this and be able to look at what's actually happening with this signal, now looking at it over 5 seconds, the different aspects of frequency, linear time, gives you some very interesting aspects. And it's nice that you can build commands like this. MATLAB has a spectrogram command. But looking at the sort of time frequency and in this tight resolution gives you some really, really valuable information. And valuable information over what the original signal is, and what might have looked even like, here's a very nice, simple little signal, in reality looks like things like this, which has so much more richness and complexity that we get in a space like this.